Hello, today we will see a program that will show you the concepts of classes, abstract classes, interfaces and inheritance. Here as you can see, I have created a project which has certain classes and interfaces. Let us go to our first class. The class name is geometry figure. You may be already familiar with the geometry. So for example, triangle, squares, rectangles, circles. Now let's see. So I have created an abstract class called geometry figure. In that abstract class, I have created a protected string called shape and I have initialized it as not defined. Then I have created a constructor for the geometry figure class which only prints out that it is the default constructor. After that, I have created another constructor for geometry figure which takes a string and set the string variable of the geometry figure to the value given. As you will see that I am using here the keyword called this. In the previous lectures, I have told you that this is used to refer to the object that you are currently working with. So this dot shape actually refers to the shape variable mentioned here. So when I set this dot shape equal to shape, value of this variable will be set equal to the value given here. Then I described an abstract method called setSize and then I describe a public method called displayShape. The purpose of this program is to only show you the concepts of abstract class, interfaces, modifiers such as protected, public and private and inheritance. Now, because I have defined an abstract class called geometry figure, I will be inheriting this class into subclasses. I have created two subclasses. My first subclass is equilateral triangle. You may already know what an equilateral triangle is. An equilateral triangle is the triangle which has all the sides of same length. As you can see that an equilateral triangle is a geometry figure. So I can see that there is a very clear inheritance relationship here. Similarly, circle is a geometry figure. That's why the circle could be the another subclass of the abstract class geometry figure. Now let's first cover the equilateral triangle. Number one, that equilateral triangle has a private variable called side because the side is a property of the triangle only. And that's why I did not declare the side variable in the superclass, which means the geometry figure class, but I am declaring it in the subclass. Equilateral triangle constructor calls the constructor of the superclass using the super keyword. And then it goes on to override the method called setSize. You may also see that the equilateral triangle is implementing area, which is an interface. Let's first cover the equilateral triangle, then we will go to the area interface and then we will come back to the equilateral triangle class to understand. Then equilateral triangle is again overriding two other methods called getArea and setArea. SetArea actually does nothing. Let's see where these methods are coming from. Area. So I have defined an interface called area. This interface has two methods. One is a getArea and one is a setArea. I have only declared these methods but have not given any implementation. In interface, we cannot give implementation of a method and we can only declare them. Similarly, I have another interface here which is called size. This interface only one method called getSize. Now every class which will implement these interfaces must override these methods. That's the reason why equilateral triangle was overriding methods called getArea and setArea because equilateral triangle class is implementing the interface called area. Equilateral triangle also is having access to its parent's class method called display shape without having any need to override or extend it. However, the equilateral triangle class must extend the method called set size, because set size is described as an abstract method in the class geometry figure. So, equilateral triangle is indeed extending the method set size and implementing it. Now, let us see what we have in the another subclass called circle. As you see that circle is also extending geometry figure, and circle is implementing area as well as size, means circle is implementing both of the interfaces. Circle has a private variable called radius. If you recall, equilateral triangle had the private variable called side. These private variable indicates that they are private to the subclass, and this is a correct approach, because had I made a radius a variable in the superclass and side also a variable in the superclass, the side would not have been useful for the circle subclass, while radius would not have been useful for the equilateral subclass. Now, the circle has constructor which is doing nothing but calling the constructor of the superclass. Then circle has another constructor which is calling the constructor of the superclass, but is also setting the radius of the circle. After that, the circle also need to extend or implement the set size function or the set size method, which is described in the superclass. For circle, the implementation of set size is different than the implementation of set size in equilateral triangle. As you can see that both methods are implemented differently. After that, circle needs to also implement all the methods of both of the interfaces, that is area and size, which circle does. Now, we have got our basic program ready, which means that we have two classes, circle and equilateral triangle. They are extending a superclass called geometry figure, and one of them is implementing one interface and the another of them is implementing both of the interfaces. Now, let us see polymorphism in action. I have created a separate class called test for testing the functionalities of the classes that we have previously created. Because we want the test class to run, that is why we need to have a main method in the test class. As discussed in the previous lecture, the main method should be declared static and public, which means that in order to use the main method, I need not to create an object of the test class. Static ensures that I can run main method without creating an object. Public ensures that I can run main method without being a part of the test class. Now, let us see what we have. We declare an object of type equilateral triangle E. E is the variable that refers to the object. Similarly, we do for the circle, where C is the variable that refers to the circle. As you see that we are calling the constructor which takes the string as an input, and we also declare a variable of abstract class called geometry figure. As we saw earlier, we cannot create objects of an abstract class, but we can create variables of an abstract class. Now, I am calling the method e.setSize and c.setSize, which essentially means that I am calling the same method for the variable of equilateral triangle class and the variable of the circle class. Okay. This is what we refer to when we mention method overriding. The set size is the same name. Method overriding allows your program to be more readable and understandable. Now, I only need to remember the method called set size, and whatever variable I will use, Java dynamic binding will make sure that the method from that class is run. In order to show polymorphism, I assign f to E and then I run the method called display shape. I also print out the area using the get area. After that, I assign f to c and I run display shape and I print out the size of c by using the method called get size. Now, let us run this program and see what kind of output we get, and then we should come back to the program to understand how that output is obtained. Our program is prompting us for an input because the set size method requires an integer input. I will give it an input, let us say 5. Then the set size method for the circle also requires an input. I will again enter 5. Now let us see what happened. First you saw that the correct set size methods were called for the variables of equilateral triangle and of the circle, and then f dot display shape was called. F was a variable of the abstract class geometry figure, but at the time of this method call f was referring to E, which means that the display shape of equilateral triangle should be called. Let us see what does the display shape method is. We have defined the display shape method in the geometry figure, and all display shape method does is print out the value of the shape variable. Now, the shape variable in the abstract geometry figure is defined as not defined. However, when we created an object of equilateral triangle class, we used the constructor which was taking the value of shape, and in our program we gave the value of shape to the triangle. Now, when the display shape method is called, it prints I am a and the value of the shape variable. Because it was referring to the equilateral triangle where the value of the shape variable was triangle, it printed I am a triangle. Then we ran the method called get area, which was a method of the interface implemented by equilateral triangle class. It calculated the area of the triangle given the length of the side and printed it. Similarly, we did the same thing for the circle. We first assigned the variable of geometry figure to the object of the circle. After that, we printed display shape, and correctly now the printout says I am a circle. After that, we print out the value of the get size, which prints nothing but the radius that was given. As you will see that for the get area size, we need separate implementation because there are different methods to calculate area of a triangle and area of a circle, or if we declare other subclasses such as a rectangle or a square or a polygon, the method get area will be different for each one of them. That is the advantages of using interfaces or abstract classes. We only need to remember the method name called get area, which we can then call for different objects and get the correct output. So, in this program we have seen the concepts of abstract classes, subclasses, interfaces, polymorphism and inheritance. I advise you to write a similar program, maybe using your college as an example, or you may use animals as an example. For example, you may define an abstract class called animal. You can then extend it to, let us say, dog and cat. Then you can say you can implement different methods which are specific to different animal categories. Try to use all the concepts of inheritance and polymorphism in your program so that you are clear that when you are using polymorphism or inheritance, what would be the expected program output look like. We have already covered basic concepts about Java, classes and objects, abstract classes and interfaces. Today we will look at some other concepts called inner classes and anonymous inner classes. The best way to learn these concepts is to write a program that displays these concepts in action. Let's see what an inner class is. In Java, an inner class is a class defined inside another class. An inner class can access private variables of the outer class, and it can be hidden from any other class of the package. An inner class is usually used to save the amount of code that you need to write while you are defining callback methods. A local inner class can be declared inside methods, and the scope of that inner class remains limited to that block of code, which is completely hidden from outside the block of code. An inner class can be specified without an access specifier, and it can also access local variables. An anonymous inner class is similar to inner class except that it does not even have a name or a constructor for that reason. It should only be used when the code is very short in size. In Android programming, we will be extensively using anonymous inner classes. Static inner class is used when you want to have an inner class which does not require a reference of the outer class. That is, there is no need to use an object of the outer class. For example, you may want to compute minimum and maximum number in an array. Another concept in Java is of object cloning. Because you create objects of a class, sometimes you may want to copy that object information. However, if you use the single equal to sign, only reference is copied, which means that now the two variables refer to the same object, and any change in the object will be reflected in the two variables. If you really want to make a copy, then you should use the method called clone. The public clone method that is available only copies the immutable data types. If you want the real copy of an object, you must implement the cloneable interface as provided by the Java, and then you should define the clone method yourself. This is the way to clone all the mutable objects. Another important concept in Java is of exceptions. Exceptions is a way to handle the errors in a Java program and to define behavior of a Java program when errors do occur in your program. For example, in C++ or in C, if you access an element outside the boundary of array, you receive an unexpected behavior. For example, you may have a segmentation fault which will kill your program, or you may receive a random garbage value. You never know what kind of behavior you will get. In Java, you may throw an exception whenever the program attempts to access any value which is outside the boundary of a given class. By defining exceptions, you can limit the behavior of the Java program. Exceptions are very useful for runtime errors. In order to use exception, you throw an exception which is then caught by a handler. Exceptions provide you more flexibility than terminating a program. Using an exception, you can keep your program running while handling an error. However, if you do not catch an exception, then your program may terminate, such as for the example given of overstepping the boundary of an array. Java does provide you exceptions which are checked and unchecked. For unchecked exception, the compiler will not check if you have provided a handler or not, and it is responsibility of you as a programmer. For checked exceptions, the compiler will check for a handler, and if you are not providing that handler, then the compiler will give you a warning and an error when you try to compile the program. A simple way of declaring exceptions is using a try and catch block. You start a try block with a curly bracket, then you continue all the statements that may throw an exception. After that, you try to catch those exceptions in a catch block. The catch block defines the action that you will take if such an exception is ever thrown by your program. So far we saw the exception and the classes. Now we will look at threads in Java. As you see that today's computers are very powerful, which means that they can do multiple tasks at the same time. The technology that enables it is called multitasking or multithreading. Multithreading allows you to run parallel lines of execution in your program. As you may have studied in your operating system course, that a thread is a line of execution and a program may have multiple threads, which signifies multiple parallel lines of execution. So, why do we use threads? Well, we use threads to support concurrent execution paths in our program. For example, if you are running a network program, you may assign a thread to receive the data while another thread is displaying some information on the display. Similarly, for GUI applications, you may assign different threads to different GUI components. In Java, you can extend an interface called runnable to implement the thread functionality in your program. The interface runnable has a method called run, which you need to implement for your class. A class that implements runnable can support multiple threads. Here is a simple example. Suppose I have a class called myRunnable which implements runnable. In that, I will have to then define a public void run method, and that's it. Now my program can support multiple threads. So, first I can create an object of a runnable type, then I create a thread object, and then I can start the thread. Please note that when you use the command thread.start or t.start, your control will pass to the method called run that you have already defined. From your operating system class, you may already know that thread may live in different states. A thread may be created, after that it becomes runnable. From runnable, it may be blocked, it may be waiting, or it may be timed waiting, and once the work of a thread is completed, it may be terminated. Synchronization. It is very important to manage a controlled access to the same data in your program when there are more than one thread is active. You may have studied about race conditions in your operating system course. A race condition occurs when more than one thread try to access the same data and try to modify it. Here is a simple example showing race conditions. Suppose there are two threads, thread 1 and thread 2. So, this is the thread 1 and this is the thread 2. They copy the same variable which has a value of 5000 into the register of thread 1, and thread 2 also copies the same value because the thread may have been switched by the operating system scheduler at that point of time. Now, as you see that the variable is copied into the internal register for the threads. So, when the control comes back to the thread, it works on that value. Suppose the first thread adds 500 to it. However, before it could store the value, it is again switched. Similarly, for the another thread which has copied the value of 5000, it also adds 900 to it. It is able to store this value again, but then the control is switched by the scheduler, and then the thread 1 which had the value 5500 stores the new value. This means that the value modified by thread 2 is overwritten by thread 1. This is a simple example of race conditions. Race condition may occur in many other programs and they may be very complex to detect. In order to handle race conditions, Java provides you locks. From Java 5.0, there are multiple types of locks are available in Java. You may have studied about locks, conditions, semaphores, mutex and monitors in your operating system course. So, we will not repeat it here. However, if you are not sure, you should try to make a Java program that uses these locks, semaphores and monitors to see the effect of each one of them. Java also provides a very simple method to make sure that your access is synchronized. Just by using a synchronized keyword, you can ensure that all the access to a data objects inside a method are synchronized across the multiple threads that are trying to access. Synchronized is like a monitor. Here is a simple code example using synchronized. Suppose I want to make sure that in my method called method name, all the data accesses are synchronized. Only thing that I need to do is put a synchronized keyword in front of it. However, there are several limitations with synchronized, as you may have already know from your operating system course. Synchronized act as a monitor, which means that it is inherently inefficient compared to a lock. Thank you. This completes our discussion on threads, and now we also complete our required background in Java for taking the course on the Android. There are many more features of Java which are used in Android programming. However, after this series of lectures, I expect you to complete that on your own. For this series of lectures, I have used the book Core Java by Horstman and Cornell. This is an excellent book which is available at multiple bookstores. You may also use any other Java book that you may be familiar with. Thank you.